Okay, we'll get started. Good morning. My name is Frank Olivier. I'm a program manager on the Internet Explorer team, and I'm up here on the stage this morning with David Katui from the Open Web Standards team at Microsoft.
Yep.
And
Hello.
Ben Constable, my WebGL developer.
Hello.
So today we're talking about cutting-edge graphics in HTML5. It's a great time for graphics on the web. We have more toys than ever before. We're a long ways away from the dark days of the web when it was just images, really. SVG came along in IE9, Canvas came along in IE9, and now with IE11, WebGL as well. We're going to talk a little bit about each one of these standards and just kind of talk in general about some Canvas things first that some people might not know about. Canvas is probably one of the easier graphics APIs to go use. As you look at Canvas code, it's really very readable and understandable to go see what happens on the screen, of course. You can read through this and see what happens on the right-hand side. There's a couple of things we've seen that people aren't really using, even though they're in all the current browsers. So, for example, Canvas image smoothing is new in IE11. We haven't seen very many people use it. It's kind of a cool thing if you're making a retro game or you're making a painting application where you want to zoom into a view. You just set context image smoothing enabled, true or false, and everything you render from that point forward changes to either blocky mode or to nice, smooth pixel mode. So, cool feature. Not many people using it yet. Similarly, Canvas full rule. You might have noticed these optional attributes on these APIs. We have support for this in IE11. And what this does really is it allows you to set the way to fill a shape that you're drawing with a path. By default, Canvas uses the non-zero winding rule unless you change it over to the even-odd rule. The way that this really works, if you haven't heard this before, if you draw a point, if you want to figure out if you need to fill a part of a path, you draw a line from that part to infinity, and if you cross, in the even-odd rule case, if you cross an even number of lines, in this case 2 lines, on the way out, then you don't fill it. And if you cross an even number of lines on the way out, you do fill it. So a simple API to use. It's kind of useful in some scenarios. You can see, again, very simple, just context.fill non-zero or context.fill even-odd. And it even works with isPointInPath. So as you change this, you can see that isPointInPath evaluates to true or false. So some nice toys that we think are cool to use. Another nice new one that's also in the Canvas 2D Level 2 spec is dashed lines. You could always draw dashed lines yourself in Canvas, but it is a little bit painful. Now we have a new way to just set your line dash segments. So it's very simple. Just pass in a little array of what kind of dashes you want. In this case, 2 pixels on, 2 pixels off. You can change the configuration here. So for things like drawing a map of all the ferries going out of Seattle, it's a very nice and easy way to do it. You don't have to go and compute all the line dashes yourself. So next up, let's just quickly talk about JPEGs. JPEGs are by far the most commonly used thing on the web. And we actually spend a lot of time worrying about image use on the web. Images are one of the most memory-intensive things we have to deal with in the browser. And there's a cool trick that can actually save you a huge amount of time in loading images and also saves you a huge amount of graphics memory. So with 2 clicks, you can actually load your JPEG images up to 45% faster, and they can use up to 40% less memory on the GPU. Now, let's quickly go through how JPEGs work. Of course, JPEGs on disk over the wire are stored not in RGB. They're stored with Luma and 2 chroma channels. When we load up JPEGs into the browser, into GPU memory, we go and convert them into red, green, and blue. And of course, that takes 24 or In the case of transparent images, it's 32 bits per pixel. But one of the cool things about JPEGs is that you don't have to have all the channels at the same resolution. So because your eye is a lot more sensitive to brightness, the luma over here, you want to store that at high resolution because that has a bunch of visual fidelity in it. But the two chroma channels you can actually store at much less, well, a quarter resolution. So how that works in practice, if you have a JPEG with 444 encoding, that's no subsampling. To reconstruct that blue sky from the previous picture, we take the two chroma channels and you add them to the luma channel, and then you get your pixel. In 422 and 420 formats, you actually sample from a lower resolution image. So the chroma channel here has 2 pixels. The luma channel here has 2 pixels for each 1 pixel in the chroma channel. So that already saves a bunch of GPU memory. So what we do when we encounter one of these JPEGs in IE11 is we actually copy over the luma and chroma channels just like this over into the GPU. We don't convert them into RGB into 32 or 24 bits per pixel. We just keep them in luma and chroma representation. And that takes a bunch less space on the GPU. If you use 420 encoding, it's even better. Again, your eye is much more sensitive to the luma channel than it is the other 2 chroma channels. So in this encoding, you actually save up to 62.5% memory on the GPU. And because we're not doing any conversion in IE11 between your YUV format and RGB format, there's a bunch of CPU time we get back. And the cool thing here as well, the naming scheme kind of makes sense if you know how it works. 444 no subsampling is really just the first 4 pixels and second 4 pixels. 22 is these 2, and 20 is just the first row and then no second row. So it's easy once you know that one. So the difference in speed if you use subsampled JPEGs versus regular 444 JPEGs. This is IE10, which didn't have this feature, and we take 81 milliseconds to decode and display the image. In IE11, if you load up the same JPEG that's been subsampled, we take 57 milliseconds to decode and display the image. So if you have a lot of images on your site, you really can save a lot of memory and time just by doing this. Very easy to do. All you need to do is in Photoshop, go File, Save As, and quality level 0 to 6. The quality slider and the subsampling options are really tied into one thing there. They don't have to be, but they are in Photoshop. But if you can go for quality level between 0 and 6, then you get this benefit. If you do save for the web, you do quality level 0 to 50, you get chroma subsampling, and you get this perfect benefit. There's also some cool tools out there that help you optimize your images. They can also do this for you. There's a very nice one I use called Riot. There's a download URL for it. This allows you to set whatever encoding scheme you want on the JPEG, and you can set 420 and downsample nicely. So let's switch over to WebGL in IE11. So we started last year in June and shipped our first version of WebGL in IE11. And since then, we've been very hard at work increasing our feature sets and increasing the Khronos test suite pass rate. We've actually shipped 4 times so far, and we'll continue to ship updates to the WebGL renderer in the next couple of months. The first version we had in June passed at around 70% in the Khronos test suite in our IE11 developer preview. In release preview and the actual release of IE, we went up to, I think, 85%. And the version that we have now at build and that customers will get through Windows Update very, very soon in the next couple of days brings us up to 93% compliance with the Khronos test suite. We're working on the next version right now, and we'll ship that as soon as we can. Our builds yesterday are on 97% compliance with the Khronos test suite. This is a printout from this morning from the various conformance test groups in the Khronos spec. that we already passed fully. So if you know the Khronos test suite closely, attributes limits, all JS programs reading and render buffers are completely finished at this point. So I'll put this on Twitter as well. So if you don't want to take a screenshot now. So we continue to work on the WebGL renderer. We've gotten lots of feedback from people on which features they want us to work on first in our beta version of our renderer. We're getting very close to completing it, and we're also looking to add more to the renderer over time. One of the other things we're working on right now is the instancing extension, and that's almost ready for release. One of the other things to talk about is the fact that IE 11 has WebGL wherever it runs. So if you're on a desktop, we run WebGL on every single device. There's a chance you might be in software mode. Very small chance in Windows 8.1. Larger chance in Windows 7 that you might be running in software mode in IE 11. But we have a very good, very fast software renderer. So in a lot of machines, it actually runs at fairly decent speed. On tablets and phones, we use the GPU always, so you always have hardware acceleration. But do keep in mind that the GPU might be a lot slower than a desktop machine. On the phone, of course, we have it turned on by default, and it's the same code and the same renderer as we have in the desktop version. So everything you see in the code we compile is the same between the two. Of course, the ARM tablets and phones have a DX9 GPU versus most desktops have a DX10 GPU. So some of the features are a little bit different, and we'll talk through that in a minute. We always get this question. We've built WebGL in IE 11 on top of our DirectX stack. IE is a DirectX application. Everything we do goes down through the DirectX stack. So it's the same with WebGL. We get our calls in through the scripting engine. We have an API translation layer. We convert all that into DirectX 11 runtime calls, and goes out to the GPU driver or software rendering. And it's the same thing with GLSL programs. We take GLSL programs, we convert them, verify them, and convert them over into HLSL and run them on a GPU. So we are a DirectX-based browser, but you as a WebGL dev don't have to worry about that at all. One of the other things we should talk about as well is software mode. There is a small chance you might be in software mode. We continue to work with all the various GPU manufacturers to update drivers where we can't run in hardware mode yet. And we continue to deploy drivers and get people back into hardware mode. But if you're on a machine where WebGL is running a little bit slowly in IE 11, do check the F12 tools. And there will be a message in there, perhaps, that says that we're switching to software mode because we want to safely display the WebGL content. So I get some questions about this every week. Check your F12 log to see if there's any software rendering messages in there. Let's talk about the Spring 14 update. This is the code that you guys just received here at Build, and this will be deployed to all IE 11 customers in the next couple of days. We'll flip the switch on Windows Update. So we'll go quickly through this list. Our GLSL conformance is much, much, much higher. It's nearly done. We have GLSL point size support on the X10 Plus devices only. The phone GPUs don't support larger point sprites. With front-facing support, Alpha WebGL context attribute. You can have access to the slides later. Let's talk about the last four in this list here. Struct support is a nice way you can really clean up your code. Before we had struct support, you had to do a bit of a workaround to go and pass around data. You had to go and put it in some other built-in type. With struct support, it's obviously much nicer, much cleaner code. Anti-aliasing is another one that we worked on that works quite nicely. Dr. do a demo of it?
Yep, I have a small demonstration of that because it's really visual. Let's go here. So I have a scene, and right now, for this scene, I will just cut off the anti-aliasing. So I use Babylon.js, which is a framework I will show you right after, but right now I just want to cut off the anti-aliasing and force it off and just load this scene. It's a big scene, but I want to show you this one. Okay, so right now anti-aliasing is off, and what you can see perfectly right there is that I'm not sure it's. Let me launch something to zoom. Yep. Right there, you see there are aliasing. Each line are drawn with just one color, and there is no system to smooth things down. So if you just engage WebGL with anti-aliasing on, and this is one of the new features of the new IE11, the same scene will just look smoother because all difference of color will be handled with gradient. So you just see things really smooth like this. Let me go to the same place. And as you can see right now, it's perfectly smooth. There is not just one color, there is a gradient. Just one line of code when you initiate WebGL.
So very easy. There is no WebGL anti-aliasing, unfortunately, on DX9 devices. So ARM tablets and the phones, you do not get anti-aliasing due to some perf concerns. But on DX10 and above, it's available. You can just set the anti-alias flag in all your content, and we will either enable it for you or not, depending on which device you're on. Another nice one is standard derivatives. We added support for that. That was a very nice feature that lit up a bunch of content on the web. It's very, very useful for bump mapping to create very, very, very realistic-looking content, like this eyeball here. It's a good thing it's not touch-enabled content. And compressed textures is also now available in the IE11 update. And you were telling me, David, that you went from 200 megabytes worth of GPU memory down to 32.
Exact, with the same result on the screen.
With the same result on the screen. So it's a very, very nice way for you to save a bunch of GPU memory again. Also, we added support for stencil buffers. This is sometimes used still for shadows or outline drawings. This is available on IE11 now, so you can use that, but we've seen people move away from this at this point. Let's talk a little bit about best practices. We do see a lot of content on the web that doesn't work very well on lower power devices. This is probably one of the challenges now for WebGL, where it's a great way to enable new scenarios on the web, but we do see a lot of people they don't handle your tablets and your phone scenarios. So that's really something we would like to see. And we're encouraging people to go and test on a variety of machines, test on phones, test on tablets, make sure that your content runs well on those devices. If you require an extension that's not available or require some features unavailable on DX9 devices, at least show a message that tells the user to go look at the page on a different machine. We still see a lot of content that just looks halfway broken on low power machines. Another big thing we see always still is request animation frame. Please use that. We do see a lot of content that renders in the background or that renders at 60 FPS even though no pixels are changing. Please take into account the user's battery, and if your app doesn't need to render, please don't render. One of the other things we've been very busy on is working with lots of different people doing frameworks for WebGL. We contribute code back to some of the frameworks to make sure that everything works well on IE. We also work with some companies that are doing frameworks for game development. We want to work with everybody here and make sure that IE11 WebGL works really, really, really well. So if you don't want to use WebGL directly, there's a bunch of frameworks that we're working very hard to ensure that we just work seamlessly and very, very fast with all of them. And one of the frameworks is Babylon.js, which David here works on.
Yep.
And would like to show more
sure.
about that.
I have some demo for you guys. The first thing I want to tell you is that the complete team is here with David and Pierre, which work with me on this wonderful engine. So if you want to use WebGL and you don't want to struggle with low-end complexity, shaders, and things like that, you should use a framework. One of them is Babylon.js. You just have to go to the main site right there, get the source, which is just one file, use it on your own project. And what I want to show you right now is just an example of how you can do that. Let me just launch Visual Studio, and we'll start from scratch. Obviously, you can use anything you want as an IDE. Let me just use Visual Studio, which is my favorite. I will create an empty website. And in this website, I have to put at least 3 things. My HTML page, some CSS, and Babylon.js. So let's first add my web page. Here, let's call it index.html. I want also a CSS, just there, index.css, and a JavaScript file, index.js. Okay, the page will be extremely simple because when you want to use WebGL, you just need a canvas. So let's add a canvas right there. The canvas will be named render canvas. And that's it for this page. I just need to reference that and put that in here. Okay, just one missing thing, is obviously Babylon.js. Just one file. Put it here, and you're ready to go. The setup is complete. What I can do right now is just change my index here to say that everyone should be full screen, so I don't want to have scroll bar and things like that, so height should be 100%. Width, same thing. And I don't want scroll bars. Okay, so let's go to the code. To use Babylon.js, you just need the engine. The engine is the main tool that covers you guys, and it takes care for you of everything related to WebGL. You just have nothing to do with WebGL. If you want to do something with WebGL, you can, but the engine is here to just protect you. So let's create an engine. This engine is on Babylon.engine, and the only things that is required by the engine is a canvas, okay? So let's just get my canvas right there. And I think that the render canvas is render canvas name, okay. Then here, my canvas. Do you want anti-aliasing? Yes, please. The next thing I can do is create a scene. The scene is just another Babylon object. The scene is a container of all that we want to display, okay? And it just needs an engine. And right after, you can create, let's say, a sphere. The sphere is created by mesh, and you can create box, cylinder, sphere, etc. But I don't want to do that. I want to show you something more professional. Let's take a scene I love, named Hill Valley. In this folder, I have a lot of JPEG files, all the texture that I need, and one JSON file here, which describes my scene. I will show you guys how to create this object right after, but right now, let's just use it. In Babylon, we have an object called scene loader. The scene loader is the object that can understand the JSON file and load it into Babylon. So let's load. The root folder is Hill Valley. The name of the file I want to load is hillvalley.babylon. The engine that I should use is my engine. It's perfect. And the completion function is an anonymous function C, which is here. Okay? When the scene is loaded, it will call me with this anonymous function and give me the scene object. With the scene object, what can I do? I just want to say, okay, when you're ready to go. Because the scene will be loaded, but the scene has to load all the textures. And loading texture is asynchronous, so you have to wait for the scene to be ready. Okay, so this function, execute when ready, will be called when the scene is ready to render, meaning all the textures, all the shaders are compiled, everything is okay, we can go. So a new anonymous function will be then used here. And what I want to do here is just ask the scene and get the active camera defined by the scene, and just ask the camera to attach to the canvas. That means that, depending on the camera used by the scene, the camera wants to handle pointer events or keyboard or whatever, and just attach control means that the camera take control of input on the canvas. Nothing more for you guys. And finally, I want to ask the engine to call for me request animation frame. I want to be sure that it works. We have also some stuff to handle set timeout if request animation frame is not present on the browser. And the only thing I have to do here is send.render. Okay, 1, 2, 3, 4, 5, 6, 7. 7 lines of code. Ah, great. A breakpoint. Ooh. Oh yeah, I know what is it. Because I use a website, I have to explain that .babylon file is a known type. So I have to set up my site right there to explain that DDS, FX, Babylon, and all files used by Babylon are regular MIME type. So we have to wait. The execute when ready will be called quickly. My UI is a poor UI. I should display some kind of donuts or thing like that. Or perhaps I have a bug because it's too, no, it's okay. So 7 lines of code, and you're in Back to the Future. So that's great. But you can ask me, okay, that's fine. How do you create the .babylon file? Because, okay, Babylon takes care of me for everything, but you have to create the scene. Yes, you have to do that. And to be honest, I'm a developer. We are all developers right there. And I'm absolutely not able to create the scene. I have to ask my friend Michel, which is not here, but I give it some credits right there, because you have to have some 3D talent, I mean, to be able to create some kind of scene. Right there, I will just do my best to show you how a 3D graphist creates a scene. Let's launch Blender. It's a free environment. You can create what you want with this. And my level of will be just here to create just a monkey. It's a monkey head. I'm so proud of it. The name of this monkey is Suzanne, which is a French name. I'm proud of it. Okay, let's just add a plane also. This plane will be there, and I can scale it. I promise. This is all I can do. When I see my friend Michel working with Blender, it's just like madness. He creates things. He can create a car starting from a box. I don't know how he can do that. Okay, and what we do with Babylon.js is that we add an extension in Blender, right there, and you just have to specify where you want to put it. Let's put it on the desktop, export my file, and on my desktop, I have untitled.babylon here. You want to test it, 2 ways to do that. You can just put it on your website, and instead of loading Hill Valley, you load untitled.babylon. But you can also, because if you are a graphist, you don't want to mess with Visual Studio and have to launch IIS locally, you can also go to our site, and we have a wonderful tool developed by David right there, which is the sandbox. The sandbox is just that easy. Using HTML5 drag and drop, you just drag and drop your resources, and you can test it. That's okay, but I think the light is not well positioned. Let's change it. Or let's do something really more fun. Here, rigid body. Let's define that my monkey is a sphere. The mass of my monkey is 1 kilo, it's okay. Let's define that my plane has the mass of 0, meaning that it's just static. And it's, let's say, a box. Just re-export it, the same place in my desktop, right? Export. And it's physics. There's nothing to do. Obviously, you can do more elaborate stuff with physics engines, which is included with Babylon.js. And you can shoot on them. Okay, the next step, the next thing I wanted to show you guys is about DDS. DDS, I tried to do something really interesting. I hope it's interesting. Let me open that site. Using the same Hill Valley scene, which right now we use JPEG because we were waiting for the DDS stuff. We can change, okay, it's this one. We will just change one thing. I will replace all JPEG by DDS, okay? Let's wait the C to open. So I have right now the source code of Babylon right there, and I just want to be sure that when I want to open a texture, okay, right now I keep the basic URL. The basic URL will ask for JPEG. So if I run this scene, this is the same thing that I just did right now. The scene will open. We have to wait a bit. 200 megabytes of textures. Okay. Yes. Oh, Blender is killing my performance. Yes. Let's do it again. Okay, this is the demo result. I don't know why the textures are not loading. I know why. The physics engine is just draining all my performance. And the thing that we just talked before is that you can stop rendering when you are not the main window. Okay, let me just start again. Okay, this is the demo effect. Sounds pretty good. Okay. I don't know why, but let's change something just right now. I will just show you the final result. What I wanted to show you guys is that these scenes here load JPEG and DDS and PNG only. And even if on the file, on the hard drive, all the files are compressed, in memory, they look like BMP. So I just save the same file here using BMP. And the size of all these files image right there is around 165 megabytes. Okay, so in memory, in your graphic card, it takes this room, right? Using DDS, the same file here, just take less than 40 megabytes. So it's a huge improvement, more than 4 times. And when you come to use some kind of small or low-end devices, it's just awesome to be able to gain 4 times memory footprint. So I encourage you guys to use JPEG, DDS, sorry. Okay. The next thing I want to show you is there. We also have offline support for you, freely. I mean, if you want to create a game or something really professional with Babylon.js, the thing that you have to keep in mind is that sometimes the network is not there, but you want to continue to be able to show your scene or your game. So, using IndexedDB and AppCatch from HTML file, you are able to use Babylon.js to load a scene. for the very first time. So everything will be loaded and saved locally. And let's remove network, cut the Wi-Fi off, relaunch IE, so no more network, but it still works. Yeah, it's good, I know. You also have for free complete physics engine with SODAT, but also collision engine. I mean, if you just want to go here, let's relaunch again Babylon.js. Yeah, and go back online, obviously. You will be able to control the user using camera. You have camera for collision. I will show you also some other interesting camera. Just by changing the camera and adding it to the scene, you will be able to use, for instance, let's go here, you know this one. You will be able to have collision. I mean, you can go through walls, through stairs, and you can walk like that. And if I want to go into a wall, it's not possible. I'm sliding on it. And if I want to go upstairs, it's possible. The collision engine, just move with me, okay? And we have the same thing everywhere because it's just pure JavaScript. So if we can just switch, please, Olivier, Frank, on the 4. Okay, so I'm on my Windows Phone Blue. The same site, exactly the same site. The same JavaScript code, the same engine works well. We are loading the scene. There is absolutely no difference in anything into Babylon.js and obviously into WebGL. And I can move right there using touch. Let's change the camera to use a touch camera. So this camera just follow my finger to know where to go. I can also use another really interesting one, which is the device orientation camera. You can just move your phone to go to the desired way. I'm not good at that. And finally, you can use the virtual joystick camera developed by David right there. And it's like in a game. You can move using 2 fingers. Just by changing the camera. So how it works on the code side. And for that, let's go back to this one. I think it's mine. No, it's not the right one. Should be this one. Yep. Let's just launch it once to be sure. Yes, it's okay. So in this one, I have a collision camera where I remove the gravity so I can fly like Superman, okay? What I want to show you right now is that with just one line of code, you can use really cool stuff. So instead of using the standard camera right there, let's change the camera and create a new camera. And the new camera I want to create is an anaglyph arc rotate camera. The anaglyph, you will recognize it instantly. Let me just define. So the arc rotate camera is a camera which is on a sphere, and you can rotate around an object and remain on the sphere. So you need 2 angles to define your position on the sphere. You need a radius. Let's say that I have a radius of 20. You need a target, what you want to look at. Let's say I want to look at the center of the world, which is 0. And let's define that I also want, it's a 3D camera. An anaglyph camera is a 3D camera. So you have to define the distance between my 2 eyes. Let's say it's 0.5. I measured this morning, it's okay. And this camera, I just have to attach it to the scene, to let the scene know that this is the camera to use for the computation. So active camera is my new camera. And finally, let's take the control. Attach control to canvas. Execute when ready. It's when ready. This is our time for a presenter because you don't know if it works. And you can put your glasses right, guys. This is an anaglyph camera, meaning that the scene is computed twice, one for the left eye and one for the right eye. And the left eye is rendered with a green filter, the right eye is rendered with a red filter, and you have 3D. Yeah, it's obvious. No, okay. Let's do some better 3D then. Perhaps you show it if you go to the Keynote 2, but I'm so happy to show it again, that just 3 lines of code. With this function developed here by my 2 friends, where is Eric? Eric, yeah, and Simon. They create this stuff, and this stuff is just really awesome. No plugin, obviously, just JavaScript and IE, and a bit of patience. Oh. This is the bone. No, please. Is there something wrong right there? I know it. No, I don't know. Okay, plan B. On the website, same one. Oh, it should be a bit long to load. It's 70, yeah, should be good. Okay, you saw it during the keynote, but we can just wait a bit. The idea here is the same thing. You compute 2 cameras, one for the left eye, one from the right eye, and how this guy works is that it uses the screen, it cut it in half. The first part of the screen is used for the first eye, the second part is used for the second eye. And what we did is that when you move the Oculus Rift, we generate device orientation data. This is the trick. That's why IE does not need any plugin or whatever, because it just receives standard device orientation data. So for IE, it's the same thing as doing that, you know? We're almost done. You just need a driver, in fact. And as you can see, I can look around. Ooh. And, oh yeah, let's go into this one. It's not easy when it's not on your head. And as you can see, it's just a few lines of code also. And I think I show you everything that I want. Yes. So thank you very much.
Thank you. So we left a bunch of time for questions. Please come up to the mics either side. And if you have any questions about Babylon.js or the WebGL renderer and IE, please fire away.
Are there any limitations to using Babylon.js in a WWA app and a Windows Store app?
Yeah, so the question is, can we use Babylon.js on a WWA application or web store apps? The response is yes, absolutely. We have a lot of samples that show you, because WWA has just IE running apps, it works perfectly. You just have to do nothing.
So I was wondering on the Babylon.js framework, if I develop a scene with...
Sorry, I can't hear.
With the Babylon.js framework, if I develop a scene with Blender, is there a way to put hooks in there so I can modify elements of that scene in code?
Yeah, you can, obviously. Everything is open source, so you can change whatever you want, even on the Blender script exportation, which is just Python, or even on the side of Babylon.
Not so much with changing the code, but I mean, can you like identify objects in the scene with an ID and then reference them from the code, or?
Into Babylon.js, you mean?
Yeah.
Yeah, you can.
Okay.
Because we keep all of the ID that you can use. No other questions? Thank you, everyone.